Dear students, welcome to my channel A8 Maths class. Today I am here with another new topic of determinants, consistency and inconsistency of a system of linear equations. This topic is very important in respect to board exam, as well as this is very important for entrance exam also, for JEE mains, advanced, KBPA, NDA. In this exam, questions related to consistency and inconsistency, as in these entrance exams you will not get the direct questions, that is the concept will be related to this topic, consistency and inconsistency of a system of linear equation. This is a very important topic. There are actually two different ways to test consistency and inconsistency of a system of linear equation. One method is using determinants, another one is using matrices. Today I am just going to discuss using the determinants. In my previous video I have discussed Cramer's rule, and some use of Cramer's rule are also there. Another one is system of linear equation and types of solution. That is, what is first we have to know what is consistency and inconsistency of a system of linear equation, what consistency means. What is a system of linear equation? It is also discussed in my previous video, in the last video in which I have discussed the Cramer's rule. I am telling again here. See the first set of equations. Here two equations are there with involving two variables, x, y, two variables, two equations. In this set three equations are there involving three variables. So this type of set of simultaneous equations is called a system of linear equation. Here it is a system of linear equation of two variables. This is a system of linear equation in three variables. Linear means all the variables are in linear power. So now what comes next, that is what is consistency and inconsistency of a system of linear equation. To define that, see this structure. For any system, either for this system or for this system, if you solve the system, then you may get a unique solution of this system. That is, there will exist only one solution. Another case, this set or this set may have infinitely many solutions. Third case, this system may not have any solution. That is, the system may not have any solution. This is no solution. So for any system of linear equation, for any system, it is either of two variables or three variables, there may be three cases regarding the nature of solution of the system. There may be one solution, that is a unique solution. There may be infinitely many solutions, and the third case is the system may not have any solution. Depending on these three types of solution, we define consistency and inconsistency. In a short word, consistency means a system having a solution. Inconsistency means the system has no solution. So for these two cases, that is, if the system has a unique solution or it may have infinitely many solutions, the system is called consistent. Clear? But if the system has no solution, then it is called inconsistent system of linear equation. So this is the definition. That is, if a system of linear equation has a solution, then the system is called consistent. The number of solution may be unique, may be infinite. But if the system has no solution, then the system is called inconsistent. Inconsistent means the system has no solution. Now in our class 10 syllabus, we have studied the same thing but in a different way. We also know that a linear equation in two variables, for example 2x plus 3y equal to 5, this represents a straight line on the graph paper. That is, the graph of this equation represents a straight line. This is x-axis, y-axis. Now how to understand the fact whether a system is consistent or inconsistent. Now see, here I am drawing three sets of straight lines. Three sets of straight line. First one, these two lines A, B, C, D. Second set, another set of two straight lines this is AB, this is CD. Another set of two straight line, this is AB and this is CD. That is, these two lines is a special case. I am coming to this, the first case. In this case, see the two lines AB and CD intersecting at a point, this one. And as we know that a straight line is what? It is represented by a, so I am writing the general equation, ax plus by plus c equal to 0. That is an equation in two variables represent a straight line. So here these two AB and CD are two equations of this form, like this. If the graph of these equations, that is these two straight line intersecting at a single point, it indicates that these two line or whatever the equation of this line is has a unique solution. Clear? In this case, the system will have a unique solution. And what will be the equation? What will be the solution? Their solution will be coordinates of this intersecting point. As their point of intersection is 1, so this system will have a unique solution. That is, the system is consistent. Now see, in this case, AB and CD, these two straight lines are parallel. Parallel means no intersecting point. No intersecting point means no solution. No intersecting point means no solution. No solution means the third case, inconsistent. Now see, here two lines, that is two coincident line. One line is coinciding with the other, that is AB. Line AB is coinciding with the line CD. In this case, how many intersecting points the lines have? They have infinitely many intersecting points. Infinitely many intersecting points means, in this case, this system will have infinitely many solution. So see, in this case, when the system has a unique solution, these two lines will represent a set of intersecting lines. Or if the system has no solution, this will represent a set of parallel lines. If the system has infinitely many solutions, they will represent say coincident lines. So in these two cases, here the system is consistent. Here no solution means inconsistent. Here also infinitely many solution means the system is consistent. So these are the three cases. Geometrically also we can find whether the system is consistent or inconsistent. Now what is our aim? Here we have to check whether the system is consistent or inconsistent by using determinants, and this method is very easy also. It is also applicable for 2 variables and as well as for 3 variables. The process is same or the conditions are same. Now see, this was discussed in my last video, Cramer's rule. Here for this case, so first let us discuss for a system of 2 variables. Here we have to form 3 determinants. This is test of consistency, so you may write by using determinants. Here we will use determinants to test the consistency of a system of linear equation. So for a system of 2 variables, here we have to form 3 determinants. First one is del. Del will be the coefficient determinant, that is a1, b1, c1, a2, b2. Take the coefficient of xy. Find the value of this determinant. Next we have to form another determinant, give it the name delta suffix x. Here how to form delta x? You will have to form delta x like this. See, a1, a2 are the coefficients of x. In this place, whenever you are forming delta x, in this determinant you have to replace the coefficient of delta x by the constant term of the given equation. So the first column will be C1, C2, then the second column will be B1, B2. Find the value of this determinant. Then we have to form another determinant delta y. In the same way, it is delta suffix y. Here this one is the column for coefficient of y, so this column will be replaced by the constant terms. So what will be delta y? First column will be same as in del. In the second column it will be the constant term of the given equations. It will be C1, C2. Also you find the value of the determinant. You just check, form the determinants and find their values. Then what are the conditions? First condition, how many cases we may have? First condition, you may get del not equal to 0. If delta not equal to 0, that is first form del, then find the value of the determinant. If this determinant is non-zero, then what does it implies? It implies the system has a unique solution. Then in this case the system will have a unique solution. This system will have a unique solution. In the first case, if delta not equal to 0, then this system will have a unique solution. As solution exists, so it will be, the system will be consistent. Now what is the second condition? For the second one, the second condition is del may be 0, del x may be 0, del y may be 0. That is, if all the determinants, values of all the determinants are 0, in this case, if this happens so that all the determinants are 0, then this system will have infinitely many solutions. This system will have infinitely many solutions. As solution exists, either it is unique or infinitely many, the system is consistent. Now what will be the third condition? In the third condition, del equal to 0, but at least one of del x comma del y is 0. Clear? The third case may be del is 0, but either del x or del y is not equal to 0. In this case, if this happens, in this case the system will have no solution. If this happens, the system will have no solution. That is, this is the case of representing two parallel lines, and as the system has no solution, it is said to be inconsistent. So these are the three cases for a system of linear equation in two variables. The system may have three cases: no solution, infinitely many solution, unique solution. Now how to check which condition is satisfied? For that we have to form three determinants: del, del x, del y. Then we have to find the values of this determinant. If delta is not equal to 0, then it is clear that the system will have a unique solution, and as the solution exists, it is consistent. Second condition may be all the determinants, values of all the determinants are 0. In this case, the system will have infinitely many solution. As solution exists, the system is consistent. And the third condition is delta 0, but either of del x or del y or both is non-zero. That is, at least one of means either del x 0 non-zero or del y not equal to 0, or both are non-zero. In this case, the system will have no solution, and hence the system is inconsistent. Hope the conditions and how to find the values, how to check the consistency of a given system of equation is clear. Now let us check this with an example. Let us take a very simple example of a system of linear equation in two variables. Let us take randomly, I am just taking an example. So the given equations are 2x plus 3y equal to 5 and 4x minus y equal to, say it is -2. We have to check the nature of solution or the consistency or inconsistency of this system. That is, we have to check whether the system is consistent or inconsistent. So for this, just I have discussed, we have to form 3 determinant and there to find their values. So how to form del? Del is the coefficient determinant. See, in the first equation coefficients are 2, 3. In the second equation these are 4 minus 1. Find the value. It is this into this, -2 minus 12, it is -14. See, this 14, the value of the determinant del is not equal to 0, so it is same as the first condition, as del not equal to 0, the system has a unique solution, and hence, since unique solution exists, that is solution exists, and hence it is, or hence the system is, consistent. You can try similar examples. You have to find del. If this is 0, then find del x, then check the value, then find del y, then check the value. If all the values are 0, then the system will have infinitely many solution. If del 0 but either of del x or del y is non-zero, then the system will have no solution, that is the system is inconsistent. Now let us check the conditions for a system of linear equation in 3 variables. The conditions are almost same, just one determinant will be extra and all other conditions are same as a system of linear equation in 2 variables. Let us take a system of linear equation in 3 variables. a1x plus b1y d1 a3x plus b3y plus c3z equal to d3. This is a system of linear equation in 3 variables, that is 3 variables are there and 3 equations are there and all the equations are in linear. So to test the consistency, we have to form here, as there are 3 variables, here we have to form 4 determinants. Now let us check how to form the 4 determinants. So what will be del? This is the coefficient determinant. See, in the first equation the coefficients are a1, b1, c1, then a2, b2, c2, a3, b3, c3. Find the values. Next we have to find del x. As in the case of 2 variables, I have discussed how to form del x. The column for the coefficient of x, it will be replaced by the constant term, so it will be d1, d2, d3, and the second and third column will be unaltered, b1, b2, b3, c1, c2, c3. Then find the value. Then we have to form del y. Del y means, in del we have to replace the column for the coefficient of y by the constant terms. So here a1, a2, a3 and c1, c2, c3 will be unaltered. In the second column we have to put the constant term d1, d2, d3. Then find the values. In a similar way we have to find del z. Here it will be a1, a2, a3, b1, b2, b3, and the third column will be replaced by this column, these values d1, d2, d3. Then find the value, expand the determinant and find the values. Then how to check? The conditions are same as that of a system of 2 variables. So what will be the first condition? If del not equal to 0, the system will have a unique solution, as in the previous case. Unique solution means the system is, unique solution exists means the system is consistent. What is the second case? In the second case, del equal to, del x equal to, del y equal to del z equal to 0, that is values of all the determinants are 0. If this happens, in this case the system will have infinitely many solution. In this case the system will have infinitely many solution, and hence the system is consistent. If the solution exists, either it is finite, unique or infinitely many, the system will be consistent. And the third case, as in the previous one, del 0 but at least one of del x, del y, del z is non-zero. In this case the system will have no solution. As no solution, the system has no solution, there is no solution exists, then the system is inconsistent. All the cases are same as for a system of two variables. If delta not equal to 0, unique solution exists, the system is consistent. If all the determinants, values of all the determinants are 0, there exist infinitely many solution, that is the system is consistent. If this one is the different one, if del 0 but at least one of del x, del y, del z, or all of them are non-zero, then the system will have no solution and hence inconsistent. You can try an example by using this condition, as I have shown for a system of two variables. You can check the consistency and inconsistency of a system of linear equation. Hope the concept is clear. What is consistency? What is inconsistency? Consistency means if a system has a solution, either it is unique or it is infinite. What is inconsistency? Inconsistency means the system has no solution. That is the case of two lines when the lines are parallel. If the three lines are parallel, then there will be no point of intersection, there will be no solution. What is a unique solution? Unique solution means two lines either in 2D or in 3D, that is in space or in a plane. If two lines or three lines, if two lines intersecting at a point, then they are having a unique solution. If three lines, what will be the case of three lines? It is like this. If you see the geometrical configuration, this is the case of three lines to have a three equations to have a unique solution. They intersecting at a common point, that is these three lines are concurrent. In this case the system will have a unique solution. Hope the consistency and inconsistency is clear. There is another method to check this thing, consistency and inconsistency, by using matrices. In a separate video I will discuss that one. Hope this is clear. If this was very helpful, please subscribe my channel and don't forget to press the bell icon to get notification of my further videos. Thank you very much.